warmer morning across the Central Plains. Temperatures up from -30 and -20 up to 9 degrees in Bismarck. So hard to believe, 35, 40 degrees warmer. And that only brings us up to 9. That shows you how intense that recent cold snap has been. And we've got 20s and even 30s in Alberta. And if you've been following the webcast, you know that's due to the downslope conditions in that area. I'll pan this up to the north and you can get a look at that. And that's basically a flow coming off the Rocky Mountains right through here. And it descends and compresses adiabatically, and we get those warm temperatures. Let me see if I can bring up a diagram of that. Let me switch over to we'll do the UCAR soundings. So you can just put that into your favorite search engine, and we'll pull up the diagram for Edmonton. And you can see that we have a pretty cold column up there, so we're extracting about the maximum adiabatic warming we can get from that and bringing these values down along the red lines. That's what gives us adiabatic warming, and surface is right there, and that brings us up to about 43 to 44 degrees Fahrenheit. So that's a lot warmer than what we've been seeing. If we take this sounding and throw a little bit of cold air in the low levels, we just have to go further west or further east, and we can see what that looks like. Glasgow, not quite there, but Flin Flon, Manitoba, yeah, there we go. So there we go. Warm mid-level column. Well, maybe not warm, but if we bring that down dry adiabatically, you can see that would warm up to about 55 Fahrenheit. So the potential is there. However, we have very cold air at the surface. There's that Arctic air mass, and we're actually seeing -18 Celsius, which is well below zero. So let's take a look at the temperature anomaly. This is the graphic we have across the U.S. for this afternoon. Coldest temperatures by far in the lower Mississippi River Valley and eastern Texas, where we're running about 20 degrees below normal. And this suggests we've got maybe a little bit of a warm front working through the North Plains, maybe like that, possibly with a surface cold front like that. So that's what we'll be looking at on the surface chart. And maybe up further north, a little bit of warm air here, so maybe we'll watch for a warm front up in the Seattle area. And things have returned to above normal in the Gulf of California area. And leading edge of the front, we can see that's probably going to be in northern Florida. It's hard to believe that front has not blasted through there, because they're 15 degrees above normal, so we're probably talking about a lot of 70s in that area. Let's take a look at the surface chart, see what's going on right now. Mostly 30s across Texas, pretty mild here. Southeastern part of the U.S. and Florida, yeah, there's those 70s. And we're probably looking at the leading edge of that front from about Titusville, Vero Beach out to Tampa. And 80 degrees at Miami. I can see why those snowbirds head down there in the wintertime, because don't have to worry about heating bills very much down there. In the Great Lakes region, starting to pick up a little bit of southerly flow, because they're on the western periphery of this large high-pressure area. So as a result, we get that return flow out of the south, and that starts bringing up the temperatures a little bit. And that also leads to a decrease in the lake effect snows. They do happen, but those are going to affect mainly the Canadian shores. So we're talking about this area, maybe part of the UP of Michigan, and maybe around the Grand Rapids area. Elsewhere around the country, let's check out what's going on in California. It looks like it's warming up. Got 67 there at Phoenix, 49 in Las Vegas, so that's about average for this time of year. And high pressure, that's going to be centered on Colorado here. So once again, we're on the western periphery. So we got a southerly gradient in place. So that'll support the development of a warm front up in Oregon or Washington. Looks like we might have it kind of in this area here. Maybe a little bit of a warm front moving northward. So with that in mind, let's go down and look at the surface map. And what I'll do is I'm going to zoom out on this. I'm going to go to the INSEP GFS, or we'll use the NAM, and do our preliminary analysis on that. That'll give us a little bit more of a wide-scale continental picture. And there, now we can see that warm front there in Washington. Can't see that so much on the close-in charts like here, the model output here, because this is just kind of offshore, off the picture. So you do have to use kind of a wider scale picture to kind of pick that out. So a warm front coming onshore in Washington. There we go. And the tail end of that old cold front, we can see it's pretty shallow because we would expect it to be kind of recurving up through Colorado, Utah, but we don't see it on the 1,000 through 500 millibar thickness. In fact, up there we kind of see maybe a warm front here and a cold front here. So this tells us the air mass we have in place is pretty shallow. If we went down to 850, 1,000, we'd probably be able to detect that. So let's see what that shows. I don't know, maybe a little bit of thickness packing in here, but you can see not so much up in that area where we have that front. So we're dealing with a more shallow air mass in this area and a little deeper with that new front coming down south. And there's the leading edge of that right there. So deeper air mass there, and we see that on the 1,000 through 500 millibar thickness chart. So actually it looks like it's way down here. So we'll just kind of draw that out and maybe put the old front through here. And there we go. So that's the frontal analysis for this evening. And one thing you can see well off to the southwest, off the coast of California and Baja California, looks like we have a cutoff low. You see that right here? And it's not actually the low we're detecting, it's the low thicknesses. So a little bit of a cold pool right there, helping to depress the upper level heights in that area. Let's see if we can pick that out on the 300 millibar chart. Yep, there it is off to the south. And these things have always been problematic with the models, especially about 20 to 30 years ago. The models were really bad at handling these cutoff lows in the desert southwest and offshore. So they had a lot of rules of thumb that they would use. They would look at approaching troughs, like up in this area here. There was a rule of thumb where if a trough approached within, I think, 1,000 or 1,500 miles, that would cause the low to open up and lift out across Texas, Kansas, and Oklahoma. But the models have actually gotten a lot better with that. So we can use that plus ensemble forecasting to kind of pick out when those are going to come out onto the Great Plains. There are still some of the most uncertain systems that are out there, but the models do tend to handle those pretty well these days. Then we'll look quickly at the 850 millibar chart. And we can see just kind of a weak cold pool near the surface right there. So area of 40 degree temperatures at 850, which is about 5,000 feet, which contrasts quite a bit with the 50 to 55 degree temperatures in the surrounding area. Okay, so let's see. Let me get everything geared up to go into the forecast. We'll pull up the GFS and get that ready, because we got Christmas coming up soon, and we're going to be wanting to see what's going to be happening then. And hello to everybody in chat. Sue says 12 degrees in Indiana. Yeah, that's pretty cold there. Here we're at 35. It's dropping pretty quickly because the sun went down, but we're doing a lot better than yesterday. 15 in Tallahassee, 15 in southern New Hampshire, and minus 12 at Sarah's Place in Indiana. So basically we're starting out with this big ridge, big high across the central and eastern U.S. This is basically that big pool of cold air sitting out over the area east of the Rockies. Just a big cold air mass that's just kind of decaying and starting to modify. And we're going to see that kind of just sitting there for a while. And then for tomorrow's webcast, we go into Tuesday. As we would expect, very stagnant pattern. Big high centered in this area, so things will be pretty fair and very cool in that region. And here comes the next system. This is coming from the Pacific, and we can see a little band of precipitation along that. And we talked about anafronts and catafronts. We can tell that that's an anafront because a lot of the precip is in the wake of that. We've probably got wind components going backwards across the front like that. And we got a little bit of a lee side trough right there. So that means kind of windy in the Denver and Cheyenne area. Then for Wednesday, continued kind of a quiet pattern. The cold front from the North Plains sinks into Texas pretty quickly. See that coming right there, driven by this 1040 millibar high. Lots of cold air advection across Iowa, Nebraska, Oklahoma, and creeping southward through Utah and Nevada. Things are pretty quiet in the Great Lakes area, warm front located in that region. A little bit of lake effect snows being implied by the models in this area, but otherwise pretty quiet. Then for Thursday, that big 1040 high drives southeastward into the central U.S. Cold front goes well to the south, so this will give us kind of a reinforcement of cold air. The strongest reinforcement is going to be in the eastern U.S. See this thickness gradient. So this is an area of very strong cold air advection. They're going to feel it the most in this region right here. So kind of a blustery, cold day in that area. Then for Friday, the rest of that cold air mass sinks into the eastern U.S., and we end up with a warm air advection pattern in Texas. So very gradual warm-up in the Central Plains going into the weekend. But we've got the next system coming on shore in California. And this is on, let's see, we're up to Christmas Eve. There we go. That system is coming through the southern Rockies. And I got to say, this is weird because the CFS model that we ran back on December 4th, if you go back and look at the videos, this is exactly what it was forecasting. So I think that's kind of a bizarre coincidence there. The models are not going to be that good, but it seemed to have pretty well nailed this. So big Pacific system coming through the Rockies right there, and you can see that's an anafront, lots of precip, trailing the frontal boundary right there, and we've got a warm air advection pattern across Texas and Arkansas, and enough to produce a little bit of shower activity in the Ozarks and into Kentucky and Tennessee. Then Santa shows up, and not much of a problem there, except for the system coming through the northern plains. This is further north than what the GFS had said a couple days ago. In fact, I think this is further north than what it said yesterday. So models are shifting things to the north, going more towards Minnesota, Wisconsin, and the UP of Michigan. So this is going to spell out another cold surge for Texas and not much else besides that. Warm front in Chicago and in Iowa, and the heaviest precip will be in this region right here. There's kind of a rule of thumb. If you take the surface low and plot out the track, you're going to find the heaviest snows to be just to the left of that track like that. So we're going to watch for that this time of year. Heavy snows all the way from Pierre, Bismarck up to northern Minnesota and Lake Superior. Then for the 26th, it's probably going to be a travel day for me. Big cold air advection pattern across much of the central U.S., driving that front out into the Gulf of Mexico. Very blustery through the Great Lakes region. Wednesday the 27th, high pressure settles in. Looks like it's developing a very active return flow pattern across Texas. Very strong isentropic lift, and maybe this could just be the cold bias from the GFS, but they're going for a little bit of freezing precip in Oklahoma. 28th on Thursday, that kind of develops and becomes liquid. And then it moves out over the central states on Thursday the 29th, up into the Great Lakes, another system kicking some cold air southward. And then we'll just forward up to New Year's, and New Year's looking like this. First chart of 2017. You can see that right there. Kind of weird seeing that New Year coming up. But there he is, very quiet across the U.S. And looks like another surge coming south on January 4th. And we'll take a quick look at the Canadian model and see if it shows anything different. We'll run this up to Christmas. And going for a very similar pattern to the GFS, bringing that up through South Dakota and Minnesota, maybe even a little further north, and it's going for more of a blizzard pattern. So we're talking about Fargo, Aberdeen, Bismarck, International Falls, and maybe on the edge Duluth. So that's going to be on the 26th, day after Christmas. And then we'll look at the European model. Europeans always stingy with their model data, but we might be able to get a little bit of usable information off this. Run this up to Christmas. There's our Pacific system coming through, either that one or that one. I think that may just be the lee side trough. Nah, I think that's the main baroclinic system, actually. So it's bringing that on the European model northeast. Okay, so we're going more for a Canadian solution, bringing that a little bit further north. So probably a good chance of blizzard right in this area. So beware of that if you're going to be that far north. Oh yeah, let's check out that cold surge in the wake, because we were seeing a big difference with that on the GFS and the Canadian-European model. Cold surge in the wake of that big storm system. Okay, GFS has trended more towards the Canadian-European solution. 1040 high, pushing southward. Okay, so that's probably going to be a little bit colder than forecast across Texas and Oklahoma around the 26th or 27th. There's that Canadian chart. 1050 millibar high the day after Christmas and on the 27th. And that's bringing the 540 line all the way down to Oklahoma City. So probably not quite as cold as this last system, but it does look like it'll be a little bit on the cold side the day after Christmas and the day after that. So that's your forecast, and let's do a quick little quick building block. For the building blocks, I'm going to do just a very brief overview of the different upper air charts. And let me find a good source for that. We'll go to Albany. And I'm just going to give you a quick rundown of what each of these charts are for. The 850 millibar chart, let me pull that back up. 850 millibar chart, that's going to be at 5,000 feet, and you're going to use that to find weather across the lower troposphere. And you're not going to use that at all in the Rockies because that's going to go underground. 850 millibar chart looks like this. In the Great Plains, we can use that to find low-level jets. And we can use this to find the upper extent of the moisture by working out the dew point temperature at each of these stations. And we can also use this to kind of get an idea where the fronts are. You saw that the fronts were a little bit hard to pick out this evening in the northern plains, but on this 850 millibar chart, we can see it pretty much plain as day right in this area. See the dashed lines? Those are temperature lines. So we see cooling temperatures up in Ontario here, and that's going to place that warm front like that. And looks like the rest of the front's going to go up north like that. So we can use this to kind of like stack that down to the surface and get an idea where the surface fronts are. And another good example, look through here, through Arizona, California, and Nevada. We can see a temperature difference there too. So there's our front right there, and we know that stacks down to the surface right there. So definitely use these 850 millibar charts if you get a chance, because they can help reinforce your surface map. 700 millibar chart, that's going to be at 10,000 feet. You're going to use this to find upper level shortwaves, small scale shortwaves. Also, the environmental mixed layer in storm situations, the cap. You can use this to find the extent of the cap. And this will help you also find your mid-level jets, your polar front jets. Like here, we can see that basically running through this area. So polar front jet pattern through here, and that's going to kind of reflect where your surface fronts are going to be. 500 millibar chart, kind of the same thing. This is the mid-troposphere up at about 18,000 feet, and we can start picking out a little bit more of the upper level waves. For instance, there's a wave right there. You can see another one here, and possibly another one right there. And then the 300 millibar chart that gets up into the jet stream levels. 300 is used in the wintertime. This is up at 30,000 feet. And looks like we're picking up a polar front jet right there, and possibly a bit of a subtropical jet. And then 200 millibars, we'll use that for jet stream analysis in the summer. This is up at about 39,000 feet. But this is going to be up in the stratosphere this time of the year, so we're not going to use that very much. We're going to preferentially use the 300 millibar chart during the cold season. So that's what we would go with there. All right, well, it's time to turn the heaters back on and relax a bit. I just came from my son's birthday party. He's 13 years old, and we had some cake and some fun there. And got to get ready for Christmas too and start figuring out gifts. So I appreciate you all watching, and hopefully we'll see you all at the same time tomorrow night, 8 o'clock. And if you have any questions or anything about the program, leave a comment on the video when it pops up in about 30 minutes. And please like and subscribe if you get a chance. Thanks.